Welcome to Geoengineer Academy. This is Petrel 2020 tutorial series. My name is Safo Macalius and I am a Petroleum Geosciences and Engineering student with a passion of helping students, researchers, and industrial professionals understand subsurface geology through practical software applications. Whether you are completely new to Petrel or already have some experience, this series is designed to take you from the fundamentals to advanced geological and geophysical interpretation. My goal is not simply to teach you which button to click. I want you to understand the geological reasoning behind every workflow so that by the end of this series, you will be able to interpret geological data with confidence and think like a geoscientist. So, let's get right into it. What is Petrel? So, Petrel is an integrated subsurface modeling and interpretation software developed for the petroleum industry. It combines geology, geophysics, petrophysics, reservoir engineering, and drilling data into one environment where geoscientists can visualize, interpret, and model the Earth's subsurface. Instead of viewing maps, well logs, seismic data, and geological models separately, Petrel brings everything together into a single project where all data sets communicate with one another. This integration allows geoscientists to build models of subsurface and makes informed exploration and development decisions. So what is the geological idea behind Petrel? To truly understand Petrel, we must understand how geologists think. The earth beneath our feet is made up of rock layers that were deposited over millions of years ago. These rock layers were formed by geological processes such as sediment deposition, erosion, compaction, folding, faulting, uplift, volcanism, and weathering. Unfortunately, we cannot simply remove the ground and observe volcanism or weathering, or let me say sediment deposition. No. Instead, we collect indirect information through wells, seismic surveys, cores, geological maps, production data, and other essential measurements. Each data set that we collect provide only a part of a geological story. So the purpose of Petrel is to combine all these separate pieces of evidence into one coherent geological model that represents the subsurface as accurate as possible. So this is a scenario. Let's say 3 of your friends went to a party and you didn't join. They stay at different places, so when they came back, you had to call one to ask how was the party. Then they told you their side of the experience. After that, you call the other, then the other. You spend a lot more time to get all this information together to know what exactly went on at the party. But in the case of Petrel, it gives you the exposure, or let me say, it gives you the room where you can make something that we call a conference call. You can call all of them on one call and ask them, yo guys, how was the party? And everybody tells you their side of the story or the experience on the same call. So that's what Petrel does. So basically, Petrel acts as a digital Earth. It allows us to recreate underground geology inside a computer so that we can study informations or the formations that are impossible to see with our eyes. So what is the relationship between real world geology and Petrel? Every process we perform inside Petrel represents something that had happened in the real world. We import well data. These well data are obtained or collected from actual borehole drilled into the earth. When we display well logs, we are looking at the measurements recorded by instruments lowered into a well. When we interpret seismic horizons, we are identifying lithological boundaries of existing beneath subsurfaces. And when we are interpreting faults, we are mapping fractures that displaced rock layers millions of years ago. So this tells you that seismic doesn't generate an image on its own, but it takes the data that you're having and with your commands generate an image for you. So this is a garbage in, garbage out software. Whatever you tell it to do is what it gives you. So by the end of this study, you will be able to navigate through the software, tell the software whatever it should do for you, so that you can create your geological models and do your interpretations. So why should anyone learn software, learn Petrel, and which people are Petrel important to? Petrel is very important and very valuable in the petroleum industry, and I'll recommend every petroleum geoscience student, a petrophysics student, a petroleum engineering student, mining and earth science student, researchers, exploration geologists, reservoir engineers, geoscientists working in the energy industry to know the software. Even if you've never opened this software, trust me, this series is going to give you a guide, a step-by-step guide that is going to inform you on what to do, that is going to give you the understanding on what to do at a particular time and what's not supposed to do, and also give you the reason for doing whatever that you're doing. Let me take you through the interface of the Petrel. So when you open the Petrel, this is how the interface looks like. We have the menu, the menu bar, which has the file, the home, the stratigraphy, seismic interpretation, structure modeling, property modeling, fracture modeling, reservoir engineering, and all the rest to geomechanics. And in each menu we have tools in the toolbar for it. So in the home section we have the tool palette, inspector, player, and all these tools for the home section. When you go to the stratigraphy, we have a different set of tools. When you go to the seismic, we have a different set of tools. Structure models, we have a different set of tools. So this is the interface of the Petrel. Also, where this Petrel is written is where your work is done. This is your working area. This is your working area, and this input section is where you load in your data. This is where your data is loaded in. So data organization, data being loaded in, everything is done over here. This models section is where all your models are saved, all your geological interpretations and models, and any model that you generate are also organized down here. And as I said, your raw data is inputted here. So this is basically the interface of the Petrel for now. As we go on through the tutorial, we are going to have a lot more interesting discoveries. We are going to understand it more, and we will really appreciate it. So what we learn in this tutorial is very simple. First, First, we are going to learn how to create a project. We are going to learn how to import data well. We are going to learn how to import seismic data, well log interpretation, fault interpretation, horizon interpretation, structure modeling, pillar grading, fault modeling, property modeling, physics modeling, reservoir modeling, volume calculation, map generation, cross-sectioning, 3D visualization, project organization, industrial best practices. And by the end of this course, you will have a solid understanding of how professional geoscientists use Petrel to solve real exploration and reservoir problems. Thank you for joining, and thank you for watching this introductory video. Hope this lesson helps you to understand not only what Petrel is, but also why it is one of the world's leading subsurface interpretation platform. And remember, learning software is only one part of becoming a geoscientist. The real objective is learning to understand the Earth's history, interpret geological evidence, and make informed scientific decisions. In the next lesson, we will install Petrel, configure the software correctly, and prepare our first project. If you found this lesson valuable, please subscribe to the channel, like the video, and share it with friends and colleagues who are interested in petroleum sciences. Thank you for watching, and we will see you in the next lesson. Bye.